Hey guys, thanks for sticking it out with me. We are on to video number 2. I just have 4 more problems to go through, and then you are free to go to your homework 7.3 on big ideas. So, we're going to continue on this problem. We are going to be continuing with finding or using the fundamental counting principle. And so we are going to use it to find how many different outfits can you make from t-shirts, jeans, and shoes in this closet. So using this fundamental counting principle, we were used to, on the past video, using it for only 2 events. Well, now we're going to be using it for 3 events. And that is t-shirts, that's 1. 2 is jeans. And then last is choosing a shoe to go with your outfit. So event 1, let's start with t-shirts. So we need to make sure how many possible outcomes or how many possible t-shirts can I choose to make an outfit. So in this case, I got 1 yellow, 2, 3, 4, 5, 6, 7 possible t-shirts. Or I'm just going to say possible outcomes. I'm going to draw a little arrow, t-shirts. Okay? Then second, I need to make sure my outfit's complete and I need to choose some pants. So we're going to choose from jeans, it looks like. And we have how many jeans that we can choose from? 1, 2, 3, 4, 4 possible jeans that I can choose from. And I spelled outcomes wrong. Jeans. All right, last but not least, I got to put some shoes on. So I'm going to choose from 1 pair, 2 pair, and 3 pairs. I have 3 possible outcomes for shoes. All right, and I'm going to use the fundamental counting principle to identify the possible outcomes for each event. So what I'm going to do, I need to first, I like to draw these little, I need to first choose a t-shirt. I then need to choose jeans. And then last, I choose shoes. Okay? And from there, I have 7 t-shirts to choose from, 4 possible jeans to choose from, and then last but not least, I have 3 shoes to choose from. So what you're going to do, you're going to plug that into your calculator. Let's go over here. 7 times 4 is 28. I already know that, but I'll show it to you. And then times 3. So overall, there are 84. Oh goodness, what did I do? I think I messed this up. 7 times 4 times 3. There are 84 possible combinations that I can use from my closet. 84 outcomes. That's my answer. That's crazy. I can make 84 outfits with that. All right, so what I want you to do next, I want you to use this scenario of making an outfit, and I want you to tell me how many different outfits can you make from 4 t-shirts, 5 pairs of jeans, and 5 pairs of shoes. Go ahead, try that, pause it, and get back to me. All right, and you should have gotten 4 times 5 times 5. And you should have gotten 100 possible outcomes. That is crazy. 100 different outfits that you can wear that are all different somehow. Okay, last concept, and that is compound events. So a compound event is this wonderful definition right here. It consists of 2 or more events. So not just one event, 2 or more. As with a single event, the probability of a compound event is the quotient, which is the division problem, of the number of favorable outcomes and the number of possible outcomes. So that's kind of represented by that formula of number of favorable outcomes all over number of possible outcomes. Okay, so that's kind of our new formula. Oopsie. New formula that we are going to be using today with compound events. So we're going to go ahead, do an example, we'll do a try, and then we are all done, guys. So our example, this is example 4, but we're going to be going back to our example 2 when we were rolling the number cube and flipping a coin. So we want to know, what is the probability of rolling a number greater than 4 and flipping tails? Okay, so there's that compound event there. I want to know greater than 4 and flipping tails. How many possible outcomes is that? Or what's the probability of it? So first, we need to know, we need to refer back to that table, or just know what are those different favorable outcomes? What do they look like? Well, we know that a number greater than 4, we need to be looking at 5 and 6, okay? And here's the other catch. It must be with tails. So the ones with heads does not count. So how many times did that happen? Do I get greater than 4 and flipping tails? So that happens. Whoa, I went too fast. That happens. We'll get there eventually. There are 2 favorable outcomes in this sample space, and the sample space is of 12. We already calculated that. For rolling a number greater than 4 and flipping tails, it happened 2 times. That is when I flipped the coin and got tails, and I got 5, and then as well when I got 6 and got tails. So that is only 2 outcomes, favorable outcomes in this case. So using my formula that we just talked about with compound events of your number of favorable on top, all over number of possible outcomes, all I'm going to do is plug in the information that I just gathered. So the probability of getting greater than 4 and tails is 2. Okay, all I did was substitute the top, the number of favorable outcomes, because I want to know greater than 4 and flipping tails, and that happened twice. All out of how many possible outcomes? 12. Okay, and make sure you reduce this or Big Ideas will count it wrong, and you should get 1/6. So the probability of getting greater than 4 and flipping tails in this case is 1/6. So kind of tricky, but I think you've got this. We're going to do a try it, and then we are done. All right, here's your try it. It is the same sample space of flipping or rolling a dice and flipping a coin. So the sample space shows the possible outcomes of rolling a number cube and flipping a coin. So from here, I'm going to know, what is the probability of rolling at most 4 and flipping heads. So go ahead, pause it, pause the video, and solve. All right, hope you gave it a good shot, okay? So what is the probability of rolling at most 4 and flipping heads? So we need to make sure in our sample space that we know what that is. At most 4. So I'm thinking, at most 4, well, I can roll a 1, a 2, a 3, and a 4. Okay, and 4 is kind of like my maximum number. And then flipping heads. Well, obviously that kind of eliminates a lot. So what I'm going to be doing is I must flip a head, so I'm only staying in this column. And I'm going to go with 1 through 4. So that happened 1 time, 2 times, 3 times, 4 times, and I'm going to kind of scale it out. 5, rolling a 5 and getting heads, it does not classify in this case. It's not a favorable outcome because 5 is too much, okay? And then the ones down here, rolling a 1 and getting tails does not classify in this event because I want heads, not tails, okay? So with this being said, there are 4 favorable outcomes. I'm using that formula of number of favorable all over number of possible outcomes. Okay, so I got 4 as my favorable. And then what is the bottom? How many outcomes are there? Well, if you didn't know, you can count all of them, but we've been using the same example, so you should probably know it's 12 at this point. And then you're going to reduce it, make sure it's simplified, and I know 4 can go into both of these. So 1/3 is my probability and my answer. Okay, so at this time, you guys are free to start your homework. Best of luck. Please reach out if you have any questions. I'm always here to help any way I can, guys. So good luck. I miss you guys.